Okay, so for today, I thought I would do a few kind of, just a little bit of like data analysis stuff. So I just kind of found this arbitrary data set, okay, online, and I thought, maybe it could be maybe it could be interesting. Maybe it could be interesting to just show a few kind of steps and things. Not that you would be working with this particular data set, but maybe some of the methods or ideas that I use here could be useful for you as you work through your group projects. Okay, and regarding the group project, I really want everybody to.
Hey, can you guys stop talking a little?
I really want everybody to kind of contribute and participate, in the analysis of the group project, and that because I think that's where the learning happens. Okay, I've been presenting a whole bunch of stuff and slides, and flipping through slides. That's fine, but really you're going to gain experience by trying things out, getting frustrated, trying things and wondering like, why isn't this working? And then you realize, oh, you know what? I need to use mutate instead of summarize, or I need to use summarize instead of mutate, or something like that, right? These are kind of common mistakes. When I use filter, I should use the %in% things, and it will also, as you work through it, you have the internet at your disposal, right? And that's an invaluable resource. Obviously, you have to be able to think and read and adapt what you find on the internet to your purposes. But that in of itself is a skill that you have to learn, and really the only way you learn it is by doing it yourself. It's not like I can show you how to. I mean, I guess I can show you how to use the internet, but anyway, I just thought I would do a little example here. Okay, so this data set, I'm not 100% sure how I feel about this data set to begin with. This came from, there is a kind of UC Irvine maintains like this machine learning data set. Let's see, UCI machine learning repository, and let me do, there's a Las Vegas Strip data set, okay? And so I don't know if you've visited Las Vegas, but there are hotels throughout the city, and there's downtown Las Vegas, which has a bunch of hotels, but then there's also what's known as the Strip, which it's kind of this, I don't know, 2-mile stretch of hotels, a lot of kind of famous hotels like Caesar's Palace and the Bellagio, and I don't know, whatever else is located along there, right? Like the Paris and New York hotels. They're all kind of along what we call the Strip. And this data set collected some reviews from a website called TripAdvisor, okay? So TripAdvisor, is a place where people write reviews, and so you can say, I want to go to Las Vegas. We'll look up Las Vegas hotels, and you can go on. I'm getting all kinds of, all right, now I'm going to get all kinds of targeted ads because they think I'm planning a trip to Vegas, which, would be fun, but, okay, and then, you click one of these hotels, and so, the Bellagio is this, I think it's a five-star hotel, and then you can read some reviews that people have left. Okay. Oh, wait, where is it? How do I find more reviews about? Okay, here. Oh, I click this link. All right, and so this place, 5 stars, right? Or 5, I don't know, 5 points. So there's So I don't know if you guys are familiar with hotel star ratings. So there is like the 5-star hotel and 4-star hotel and 3-star hotel. And that is not how, like, actually, it's not what reviews people have given that, okay? It's like what amenities are available at the hotel. So in order to qualify as a 4-star hotel, you need to have like, you need to have a pool and a restaurant on the premises of the hotel, okay? And then if you want to have like be a 5-star hotel, you need to have like a gym on the premises of the hotel and things like that, right? And I don't know, there's like all kinds of different rules and stuff. And if you don't have the restaurant, then the highest you can get would be like a 3-star hotel and things like that. And so that star rating for the hotel is like what kind of amenities are available. Meanwhile, you can be a 5-star hotel and get, when people leave reviews for your hotel, it could be like 2 stars. It could be like, or 2 points or whatever it is. They could be like, oh, the rooms were dirty, or the staff was unkind, or whatever, right? People complain about everything, right? And so this is so anyway, what this data set has done is, I guess there is a paper. Here it is, okay, and you can look up this paper, and they went. This is like there's all kinds of different academic journals. And apparently there's an academic journal for hotel management practices. Okay, tourism management perspectives. And so I guess people who are in the kind of hospitality industry, maybe they write articles and stuff. And this is kind of like an academic thing. And you could read through, we're not going to read through this thing, but they talk about the information they collected. And so they collected back in 2015. And so some of the website has since been, remodeled and stuff. So what you see on here is a little bit different. But anyway, what they did was they went through and they picked a bunch of hotels along the Strip. So there's like the Circus Hotel and Casino, the Excalibur Hotel and Casino, the Monte Carlo Resort and Casino, Treasure Island Hotel and Casino, Tropicana, and I don't know, they're always kind of like building new hotels and tearing down hotels, I think. So they picked a handful of these things, and then they collected some random reviews. I think for each hotel, they just, and I'm not, I didn't read the paper all the way through, so I'm not sure exactly how they did it, but they collected 24 reviews for each hotel, and I think they tried to get 2 reviews per month. So they did like 2 reviews in February for Circus, 2 reviews in March for Circus, 2 reviews in April, and so on and so forth. And 2 feels like a really small number, but I think that's also because not everybody leaves reviews. And so like if you try to find reviews for a particular hotel, it might be tough to find, like, I need to find like a bunch of reviews from April of, Treasure Island, and maybe that's kind of hard to find. So anyway, they did 2. We have a total of 504 reviews. So anyway, I just thought 504 divided by 24? So we have 21 different hotels, 24 reviews each. And some of the they looked at information about the user and how many reviews that user has written. So this, some, you see some people, like, they love writing reviews on TripAdvisor, right? That's like everywhere they go, they write reviews, and they have, I guess if you're into the TripAdvisor community, you get like points, right? There's like every place where you can contribute something, there's like, you get some points, right? So you have like, big YouTube stars and TikTok stars, and I guess there's TripAdvisor star review writers, but I don't know. Okay, but I mean, even Amazon, it'll be like top 5,000 reviewer or something. And you're like, oh, I guess maybe what you have to say is important. So this is the score that they left. And then the period of stay, they looked at which variables they're, which months, in which months that they wrote the review. And it could be, December through February is generally considered a slower period for maybe like vacationing, okay? Whereas, June through August is heavier, and then, March through May, September through November, somewhere in between, generally. And then, traveler type, and then this is, so it's, the way they compiled this data set, I don't 100% know how I feel about it, because each row is like an individual person's review, but then they also included like variables that apply to the entire hotel, right? Like all of Circus Hotel and Casino Las Vegas, it would be really strange or bizarre if pool was yes for one person but no for another, right? So this is, it's all going to be the same. So apparently there's no pool at the Circus Hotel, but there is a gym, okay? And apparently you also have free internet. Sometimes these things change, right? So you're like, oh man. Well, and then, I don't know, they all charge a resort fee, which is, whatever, okay. And then, so this is all like information about the hotels. This is a 3-star hotel, and the number of rooms, apparently there's 3,700 rooms at that, which seems like a lot, okay? But then now we have information back about each user, all right? So the user who left the review is, either from North America or Asia or Europe or Oceania. And I guess, I don't know if we have South America or Africa represented in this data set. But maybe people just, okay. There is Africa, yeah. But, perhaps TripAdvisor or Las Vegas isn't as popular of a destination. I mean, like, if you're from South America, why come to Las Vegas when you have like other, I don't know. But, okay, and then, I guess how many years the member's been on the site, and review months, review weekdays. All right, so there's all kinds of like interesting, analyses that we can do. So I just thought, let's do just a couple example analyses of some of the things to that you could say, try out. So let me, I'm going to import the data. I have this stored under my week 6 folder. So I'll just kind of read that in, and that looks fine. Sometimes you might want to take, some of these things. So hotel stars, it says double, it looks like a number, and maybe I want to do that, leave it as a double. I also might want to turn it into a character, just because, well, I don't know. Okay, but I'm gonna just go ahead and leave it as is. But you can kind of go through each column and click import. And the way I did this was I went to import data set from text. If you have a CSV file, that's basically what you shall do. Okay, so kind of the some of the first things I'm going to do. Well, let me call in library tidyverse. And here, you know what I'll also do? I'm gonna move my face down here, and I'll make a little markdown file so that I can.
Is it time for a view quiz answer?
Oh, you guys want a view quiz answer?
We need a quiz. No, but everyone needs to bet equally on.
No. Okay, whatever. Okay. All right. First answer is the letter A. The letter A is our first answer. Okay. A as in apple. A as in apple is your first view quiz answer. Okay, so library tidyverse and when you call when you use this import data set, okay, it's going to it'll enter like code into the console, and then to kind of retrieve that, you can copy and paste that into your thing. Now you want to make sure you don't copy the view command. That's like because that pulls it up here, and that only applies that only works while you're inside the thing. Okay, but actually,
how'd you make that code come out? Yeah.
So when I clicked import dataset and I did from text, and I did, you go through the process,
Yeah.
it inserts code into the console.
I see.
All right, and then you can just copy and paste that code from the console. And actually, this data set name is like way too long, so I'm gonna just change it to Las Vegas. All right, I'm gonna go ahead and I'm gonna delete the values in my environment. And I'm gonna just run this again. Okay, so I'm gonna just create a data set called Las Vegas, and now that's gonna be easier for me to work with. Okay, so let's start by kind of exploring this, all right? And so, other professors might be anti Excel, but I'm a fan of Excel. Okay, at least for like browsing and stuff. I recommend trying to avoid Excel to do a whole lot of data manipulation. You might want to just go through and if you can do like a find and replace on Excel and stuff. I would recommend avoiding to doing that, because to replicate your steps and processes is, you have to kind of document that separately. So, but if you do it within a script, you can kind of replicate some of these things. Yeah.
What are the other professors like pro for? So they don't like Excel, then what do they use it?
They like R.
Oh.
They like R, and then.
For for making data sets like that, they're using R to do it.
I guess, I don't know.
Oh.
Oh, I shouldn't say all the other professors, but yeah. Okay, so let's just start by taking okay, let's just take a look at some basic things about, say, the hotel, and let's just look at the average score, okay? The mean score for the hotels. So I'm gonna do Las Vegas, and I'm gonna group by, and the variable is hotel name, okay? Group by hotel name, and then, summarize. We're gonna create a few variables here. So I'll call this average score, and this will be done by taking mean of score. Whoops. And is there anything else I want to do right now? I mean, there's probably a whole bunch of stuff, but also some of these, again, because of the way this data was collected, certain things won't be as useful per se. But okay, so we'll start with this, and let's just take a look. Okay, and this we got. This is what we have, and so in alphabetical order, these are the scores here. You know what? Let's arrange this. Arrange by average score, and let's do it in descending order. So the highest hotel first. Who do you think is the highest rated hotel based on the Wynn, and then the Venetian, and the Encore, and the Marriott, and the Palazzo? Okay, Trump International, Wyndham, Grand Dessert. Okay. All right. So that's what we have. Those are your top 10, and then you have all of these things ranked 21. What do you think? The ignominious circus. Okay.
Oh.
All right. Oh, all right.
No pool, that's why.
Because they have no pool, and it looks like a giant tent, which I guess is the appeal, but maybe it doesn't appeal to everybody. All right. Okay. So that's like a very basic type of a thing that we can do. And now we can say, all right, well, what if, let's look at just kind of I'm curious about hotel star rating, okay? So like the 3-star hotels versus the 4-star hotels versus the 5-star hotels, right? So it's, rather than grouping by hotel name, what do you think? Do you think 5-star hotels will have, so what's it called? It's called hotel stars. All right, so group by hotel stars, okay? And because there's a space, you have to put little backticks around this. All right, and so here I'm not gonna arrange by descending score, but we'll just kind of do this. Oh, and look at that. The 3 stars average rating is 4.0. Hotel, 4-star hotel gets on average 3.88, and the 5-star hotel gets a 4.38. Okay, and so the question is, okay, maybe at the 5 stars you go in with high expectations and then they're met, right? And then maybe if you sign up for a 3-star hotel, you go in with like lower expectations, and so you're like, oh, this wasn't so bad. I don't need a pool. This was great, right? I'm not here to go swimming. I'm here to, play the machines or roll dice or whatever, right? Who needs a pool for that? Okay. And I don't know. I don't know what's going on, right? I'm surprised the 5-star is actually as high as it is, because a lot of times when you say when you hype something up, a lot of times it's easy to fail to meet this thing. Okay, so here's this, right? And now, let's say the question, one of your questions should always be like, is there actually a statistical difference between these numbers, or is it just possible that these are like randomly sampled things? Maybe there's not a statistical difference. Let's go ahead and just take into account some of these things. So I'm going to do standard deviation of the score, which will be SD score. I'm going to just add a few more variables, and then I'll just do count, which will just be n. Okay. All right, so we have pretty, actually the standard deviations are all fairly consistent of around one, and even for the 5-star hotels. And okay, and then we have, fairly equal counts here. Okay, so if we wanted to compare multiple means, so if I said, so comparing 2 means, if we wanted to say, is the 3-star average of 4.02, is that different from 3.88? We could do a t-test, right? So how would I go about doing something like this? I'll do Las Vegas, okay? So there's a few ways we could do this, right? So I can create a vector called 3-star scores, okay? And so for this, I'm going to take Las Vegas, and then I'm going to filter. Here, I'm going to do Las Vegas, filter, and we want hotel stars to be equal to 3. And then we're going to select score, and then we'll pull it. Okay? Oops. Pull is a lowercase p. Okay. So we'll do that, and this looks about right. Okay, 3-star scores. So in my environment, I see there's a vector of 168 values, which matches what I have here. So this is going to be, this creates a vector, right? And then so I'm going to do the same thing. And instead of 3, I will do the 4-star scores. And hotel stars, we'll do 4. Okay, and here I have 144 values. And to kind of just do compare 2 means, I can do t.test 3-star scores versus 4-star scores. Okay, so this will be maybe I'll write some commentary. So the average score for a 3-star hotel is 4.0238, and the average score for a 4-star hotel is 3.888, okay, is there a statistically, all right, I'll just say, are these two averages statistically different? Okay, so what do you guys think? 4.02 versus 3.888. Different, the same?
Different. 168 is a pretty high count.
All right, well, let's see. We get a p-value of 0.236. So according to this,
Not different.
yeah, so
3 and 4 were actually closer than 3 and 5.
yeah, we can ask about 4 and 5 and 3 and 5 and stuff like that, right? Okay, so the p-value is 0.236, indicating that we do not reject the null hypothesis. And so, our data does not provide enough evidence to say that the average score of a 3-star hotel is different from the average score of a 4-star hotel. Okay, but then and we could do the same thing with 5 stars, right? Whoops. So I already have the 3-star scores. All right, so maybe we want to do 5. Hotel stars is equal to 5. And then, all right, so we'll ask if the 4-star scores and the 5-star scores, is there a difference there? All right, are we okay with the code that I'm writing? Like, we're able to kind of follow along each of these steps? All right, so we'll run that. And this says, but there is a significant difference between this average of 3.88 for 4-star hotels and 4.38 for 5-star hotels. That is significant, right? So there is a significant difference. Okay. 4 and 5-star hotels. Okay, p-value is, 7.37 times 10 to the, e to the negative 6, right? So this is like very close to 0. Okay, so that's one possibility. If you wanted to compare multiple means at the same time, do you know how to do something like that? So here we have three groups, right? We have the 3-star hotels, the 4-star hotels, and the 5-star hotels. Yeah.
I don't know how you would code it, but you do a pairwise comparison.
Do you like the cross?
Chi-square test? Homogeneity.
So if you're comparing 3 means, comparing multiple means, you're going to do one-way ANOVA. One-way ANOVA is so you can do kind of pairwise comparisons, which is kind of what we did here. I only did 2. There's 3 possible comparisons here: 3 versus 4, 4 versus 5, and 3 versus 5. Yeah. If you have, I'd say, more than 5 groups, then you got like a whole bunch of comparisons to do, and you run into this problem of the problem of multiple comparisons, which is like this whole other thing. But it's the idea that if you keep slicing your data and keep doing all of these different tests, you might end up thinking there's a significant result when it's just kind of it's just due to randomness because you've done so many of these things. Okay, there's actually like a little comic worth. This is like a side note. Problem of multiple comparisons. Here, let me do XKCD, jelly beans. Okay, and so this is a comic that kind of illustrates a little bit of this idea of like just running a whole bunch of tests of like kind of the same question, but where you just slice it a slightly different way, right? So, so this comic was created a long time ago when like Minecraft first came out, and now Minecraft's been around for what, like 2 decades? I don't know how long it's been around, but it's been around for a long time. But anyway, okay, so there's little references to Minecraft here. But it's, it starts off, the person says, jelly beans cause acne. And then the scientists investigate, and they come back and they say, we found no link between jelly beans and acne. The p-value is greater than 0.05. And then they object and say, I hear it's only a certain color that causes it. And so they say, scientists, investigate. Okay, and they start off and they say, we found no link between purple jelly beans and acne. P is greater than 0.05. We found no link between brown jelly beans and acne. P greater than 0.05. We found no link between pink jelly beans and acne. P greater than 0.05. And it keeps going on. They test every single color, okay? And these colors had no link. All of their p-values are greater than 0.05. They test all of these colors, salmon, red, turquoise, magenta, yellow. No link between any of those colors. They're doing each of those colors individually. No link so far, okay? And then it says, we found no link between cyan jelly beans and acne, okay? And then it says, we found a link between green jelly beans and acne. P less than 0.05. We found no link between, and then it keeps going. We found no link between mauve jelly beans and acne. We found no link between beige jelly beans and acne. We found no link between lilac jelly, okay? No link between peach jelly beans. No link between orange jelly beans and acne. Okay. So when you see it kind of like this, they've done basically 20 different tests, for 20 different colors. And for 19 of them, the p-value ended up being greater than 0.05, but for this green jelly beans, we ended up with a p-value less than 0.05. So do you think there's a link between green jelly beans and acne? So the p-value here is small, and if we did this all by itself, then we'd be like, oh yeah, maybe there is. But the fact is when you do a whole bunch of these things, like just kind of by coincidence, you're gonna end up with something that looks a little bit strange. So if this were the test, what's the news article that gets published? Green jelly beans linked to acne, right? 95% confidence, only a 5% chance of coincidence. But the reality is we go, yeah, you know what? We did like 20 of these things. There's probably a decent chance that it was that coincidence, right? It was kind of that coincidence. And it's not, again, you're not guaranteed that this is always going to happen. There really could be a link between green jelly beans and acne, but it's also quite possible that the link that we seem to see here is just like a coincidence of this particular data set, okay? And similarly, if you have like 10 groups, and you do a whole bunch of these different tests, you might have to do like 20 different comparisons. Group A versus group B, group A versus group C, versus group D, versus group E, group versus group F. And then you have to do like B versus C, B versus D, B versus E, B versus F. And you keep going, and you end up doing like 20 comparisons, and you go, oh, you know what? These two things look different. And it's like, oh, you know what? Maybe it's just a coincidence of the data, right? When you do a whole bunch of those types of tests.
So that comic example, you're basically saying there's like a 1 in 20 chance that it happened by luck? Or can you say it like that?
So your p-value will end up less than 0.05 by luck 5% of the time.
Mm-hmm.
Okay?
Yeah.
And technically every single time is not independent of each other because you're using the same data set and stuff, but
like jelly bean.
Yeah, there is you could end up finding some kind of link just kind of by coincidence. Let me give you your second view quiz answer, which is the letter C. The letter C is your second view quiz answer.
Yeah, it's a bad bit.
Split the bets.
Last one,
If it comes up once.
Okay, so
You bet successful.
so one thing, okay. So be careful about treating categorical variables as numeric, okay? This is something I will punish very harshly for on people's reports, is if you treat a categorical variable as numeric or vice versa. Oh, well, okay, a numeric variable can be treated as categorical under if you like make it clear that this is what you want to do. Okay, so for example, these 3-star rating, 4-star rating, and 5-star ratings, they look like numbers. They look like 3, 4, and 5, but I would argue that they are actually categories, not really. You know, when you have numbers and you have like a 6 and a 3, like the 6 is twice as big as the 3. Okay, and that makes sense when you say someone is 6 years old and someone's 3 years old. The person who's 6 years old is twice as old as the person who's 3 years old. That's a correct thing to say. And the person who has 6 siblings has twice as many siblings as the person who has 3. But here, I don't know if we can say, you know, 5-star, you know, is 25% more than the 4-star or something like that. Okay, so
So that's what you would penalize if we compared categorical variable like that?
All right. Well, okay. Hang on a second. Okay. So here I'm going to do AOV for ANOVA. This is a one-way ANOVA. ANOVA can be used to compare the means or the averages from across multiple groups, across multiple or like, you know, 2+ groups.
What's ANOVA? Analysis of variance?
It's analysis of variance. Okay,
Would we be able to chi-square test it? And is it
so chi-squared tests are for categorical variables. You don't use chi-squared tests for means. Chi-squared tests for categorical variables or proportions. So chi-squared wouldn't work in this case. If we had 2 kind of categorical variables, that would be the appropriate test to use. Okay, so let me. So what we're going to do is we want to do score. And you do score tilde, and here I'm going to do it the wrong way first. Wrong way is treat hotel stars as numeric. Okay? And I forget, is hotel stars capital H, lowercase s. All right, and data is Las Vegas. Yes, question.
So the reason it's categorical is because it's not actually representing a numerical value. It's just representing the amenities of the actual hotel, right?
Yeah, it's more like a classification. This is a Class A hotel. This is a Class B, and this is a Class C. And
if you were to take, instead of the classification stars, if you were to take like Yelp review stars, that would be numerical then, right? Because you could average that.
Yeah, you could average things and do kind of a comparison between them. You know, an argument could be made that, you know, Yelp star, it's a little, you know, 3-star ratings, 4-star ratings, 5-star ratings for like Yelp stars. You know, an argument could be made either way. And finding like an average between them, you know, might not be. So one way is to treat hotel stars as numeric, and if the variable is numeric, one thing is the value for degrees of freedom is going to just be 1. You get 1 df, which is basically like its slope. Okay, so it's trying to like calculate a slope for the star rating. The correct approach, and again, you know, is to treat hotel stars as categorical.
Wouldn't that make it possible to chi-square test it if they're categorical?
Huh? So I'm going to wrap hotel stars in something called factor. And that's going to turn it into a categorical variable. And again, you know, feel free to, you know, stop by office hours, right? Some of you I see like every day at office hours, which is great. But others of you, I don't know if you've ever stopped by office hours. And then there's a bunch of, and I'm not even talking to you in this class, but you on the video watching. You know, some of you, I don't even know if I know your faces because I don't know if I've seen you in class very much, and I don't know if I've seen you at office hours. But, you know, come by and ask questions about your data analysis. I'm happy to kind of steer you in the right direction, give you advice, tell you how to do these commands. in R and things like that. I want you guys to do a good job, and I want you to know that I am available as a resource here. Okay, so here when you do factor on this, okay, when treated as a categorical variable, the degrees of freedom, or the DF, equals the number of categories minus 1. Okay, so this would be the correct approach. We have 3 categories: 3-star, 4-star, 5-star. Okay, 3 categories: 3-star, 4-star, and 5-star. So a total of 2 degrees of freedom. Okay, and I don't want to get super into like ANOVA analysis and because that's like, you could take an entire course on ANOVA, and actually that's Stats 101B is all about ANOVA and designing your experiments and things like that. And so, I don't have time to do all of the intricate details of ANOVA, but like one of the basic things is, if you're going to treat it as numeric, you're just basically estimating a slope, and you're going to have like 1 degree of freedom. And what is a degree of freedom? I don't want to feel like explaining it right now. Okay, but then if you have like multiple categories, you take the number of categories minus 1, and that's going to be the number of degrees of freedom. So in both of these cases, we end up getting these tiny little p-values, which indicate that they're significant. So here, the p-value is 1.09 e to the negative 5, indicating that the variable hotel stars is statistically significant, meaning that it plays a role in the score that the hotel receives. The unfortunate thing is it doesn't tell you which one is different. Okay, so an unfortunate shortcoming of one-way ANOVA is that it does not tell you which score is actually different. So that's where you still have to do kind of the multiple comparisons, where we did, 3 different from 4? That analysis came back and said no. But is 4 different from 5? That analysis came back and said yes. Okay, and I guess I could also do like, is 3 different from 5? Is the average for the 3-star hotels, 3-star scores and 5-star scores, and that is significant. Not as significant as the 4 versus 5, but the the average for 3 stars was 4.02, and the average for 5 stars was 4.38. So really, the 5-star hotels have kind of distinguished themselves as being quite different from the 3-star and 4-star hotels, and maybe there is something to it about staying at a 5-star hotel. Okay, I only got to do a tiny bit here. Is this good? Should I continue like doing more of this on Friday, like doing a little bit more of like digging into a data set like this? I want it to be useful versus like, if you want me to go back to the slides, I can go back to the slides and stuff. But I want to kind of demonstrate like some of the kinds of things to do. Obviously in the report, you'd have to like type out a little bit more of your explanation here, but I just wanted to show a little bit of like some of the code, and maybe I'll annotate before I upload onto Canvas.
This is really helpful. Yeah.
Last view quiz answer for today. Last view quiz answer for the day is E as an elephant.
Oh God.
E as an elephant. Okay, yes, question.
Can you upload this from
Yeah, I will upload this to Canvas Brew and Learn.
Yeah, I can't say one of them.
Okay, final view quiz answer today is E as an elephant. All right, have a great day. We'll see you all on Friday.